Hello students, today we are going to learn about CPU instructions, and in particular we will learn about categorization of instructions by the number of addresses. So directly coming to the topic, see whatever I have been telling, these are some definitions you have to just keep in mind as it is, and all the points will be cleared by the examples in upcoming slides. Okay, it will be super clear after the examples. Okay, now what are instructions? CPU or processor instructions. See, these are set of codes input to processor to perform a particular activity, and the instructions usually consist of, means this is what the architecture of instruction itself. When you are writing the instructions, it is composed of an opcode. What is an opcode? Opcode is to perform a particular operation. The operation can be to add two numbers, to multiply two numbers, to move data from one register, one location to another, like this. Okay, so you will write the opcode first, and then you will write the target location or address where that opcode will perform its job. Okay, there must be some location, some memory address where opcode will perform its job, and then you will write the operand. For after this address you will write the operand. What is the operand? Operand is the data on which the opcode has to perform. Okay, so address is the point where the opcode will perform, and operand is the data on which the opcode will perform. Okay, now again, instruction categorization by number of addresses. Just you have to learn this point by examples. It will be clear. Okay. See, by instruction categorization by number of addresses, it means that when you are writing the instruction, then the instruction is handling how many maximum number of address points. Okay. According to that, the instructions are categorized. Means at this point, target location addresses. Okay. Here, how many addresses the instruction is using. So the instructions can be categorized in that way. So this is what the meaning of this points, instruction categorization by number of addresses. So it can use 3 addresses, 2 addresses, 1 address, or 0 address. Okay, now with example I will tell. 3 address instruction, it means what, that in the address section, here it is, in the address section it will use maximum 3 address locations. For example, suppose I say these are the registers A, B, C, D in which operands are present. Means A contains some data, B contains some data, C and D also contains some data, and we want to perform this activity. Means add A plus B, then multiply with C plus D, and then I want to store it in register R3. Okay, now in 3 address instruction the codes can be like this. See, the first will be the opcode we have to add. So add R1 comma AB. It means what? The processor will understand it like this. It is compiled like so, that add the numbers which are in registers AB and put it in R1. Okay, add A and B's value. A is the register, B is the register, and put it in R1. Now next instruction will be add R2 CD. Okay, so the meaning of this instruction according to processor is add CD and put it in R2. So this R1 and R2 are called as target registers on which ultimately the finalized outcome is kept. Okay, now third instruction is multiply. This MUL means multiply. Multiply R3, R1, R2. It means what? Multiply the values of R1 and R2, because in R1 it is present A plus B, and in R2 it is present C plus D. Okay, so multiply R1 and R2 and keep it in R3. Okay, that's it. So our final job has been done, that the value has been kept in register 3. Now this is called as 3 address instruction. Reason being, at a time after OR code, you can see 3 addresses are mentioned in maximum. It can be 2 or 1. Okay, but maximum 3 addresses can be handled at a time. Now 2 address instructions. First of all, it will handle maximum 2 addresses in its address section. The same example, A plus B into C plus D we have to perform, and whatever the result is, we have to store it in register R1. Okay, so the codes can be like this. So move R1 comma A. It means what? Whatever the value kept in A register A, move it in R1. Okay, so R1 will contain the value of A. Now add R1 B. It means what? Whatever the value contained in B, bring it and add it in R1 itself. Okay, so in R1 A plus B is present now. Now move R2. R1's job has been done. Now move R2 comma C. It means what? Whatever the value present in C, bring it in R2. Now add R2D. It means what? Whatever the value which is present in D, bring it and add it in R2 itself. Now in R2 there contains C plus D. Okay. Now R1 contains A plus B, R2 contains C plus D. Now the last instruction will be multiply mul R1 and R2. It means what? Bring R2 to R1, multiply and keep it in R1 itself. This is the target register. Okay. So final job has been done. The A plus B into C plus D is kept in R1. So what you see that in all instructions, maximum 2 address points are used. Unlike that of in case of 3 address, you can see maximum 3 address points are handled. Here in one instruction, maximum 2 address points are handled. Now, one address instruction. Okay. Again, it will use only one address for executing the code. In one address instruction, there is a difference as compared to that of 3 and 2 address instructions. That is, it uses a helping register that is called as accumulator. Okay. So this accumulator AC is a register to store the results temporarily. Okay. And after then those results can be utilized for further processing. Okay. Again, the same example I am taking. Suppose I want to add A plus B and then multiply with C plus D. A, B, C, D are the registers. Okay. And store in register R. Okay. Now in this case, what happens? Load A. The code is different, you can see. Okay. So load A means what? However, I must write it load R comma A. Okay. Only load A is written because if there is only one register, only one address instruction is there. So again and again, why in the code R will be written? It will save the data because when we are writing the address, it needs some data in binary format. So to save that data, again and again, we don't have to write R. Here it is R1, R2. There are two different registers. Here R1, R2, R3, three different registers. Here only R is there. So no need to. So load A means what? It will automatically take the value of A and put it in R. It is compiled like so. The codes are compiled like so. Okay. Now add B. So whatever the value of R is, B is brought and added to R because the operation is performing in R itself. Okay. So whatever the value is there in the R, it is stored in AC. So I have already told about this accumulator register AC in the beginning. Now R is free. Now again load C. So automatically it will put the value of C in R. Now add D. So it will bring the value of D and add it in R. So in R already C was present. So C plus D. Okay. Now in R there is value C plus D and in accumulator there is value A plus B. Now mul AC. It means what? Automatically it will bring the value of accumulator register AC and will multiply in the R itself. So ultimately in the R we will get A plus B into C plus D. So this is one address instruction format. Now zero address. So zero address means not using any address at all. So it will be clear by the example first and then I will come to the definition. See what happens in case of zero address instruction. There is a stack of memory elements in queue and this stack can be in the RAM. There is a particular portion of RAM in which there will be the stack, or it can be in cache memory and it is programmed stack. Okay. Now instructions are like this, that push A, same example I am taking, A plus B into C plus D. So push A, what will be done? That it will put the value of A in the top memory element. Okay. As I will proceed, you will understand. Now next, push B. What will happen? A will be shifted below, in the top B will come. Okay. Now next, in case I put the opcode at the top, what will happen? That opcode will work with the immediate top two address points. Means in case I write add, what will happen? It will automatically add the values and put it in the top memory element. Okay. Now push C, next instruction. So C is pushed, is sent inside at the top, and B plus A moved one address below the C. Now push D, you can see now D is pushed inside. So C has gone below and B plus A gone below C. Okay. Now add, what I told, when I will put the opcode, it will perform that opcode in the immediate top two memory elements. Okay. So when I will write add, automatically it will add the top two memory elements. Okay. Now what I have to do, since it performs the opcode on immediate top two memory elements. Okay, so in case I write multiply, automatically it will do this, D plus C into B plus A. Okay, and at last, suppose I want to keep whatever the data is at the top, I want to keep it in register X, then I can write pop X. Pop is for removing the data or shifting the data from top to the register where I want. Okay. So this is what zero address instruction method of execution of commands or instructions. Okay, so coming to the definitions, see, in case of zero address instruction, there is no as such register where the operand has to be brought and processed. Okay, there is no as such, you have seen there are push and pop operations. There is a programmed stack which can be at RAM, cache memory, etc. Okay, now this is the main point. The stack system is based on the fact that at a time only two operands will be subjected to an operation. Here what you see, A, B at a time, B plus A is happening, then C, D at a time, D plus C operation is happening. Now at a time, this D plus C and D plus A operation will happen like this. Okay. So the entire program can be broken into series of two operand operations. Okay. Now, in one operations, two operands are processed to get the result. It will be a third operand, A, B, A plus B. This A plus B is third operand. Then the third operand is processed with fourth operand to get the result, and it will become then fifth operand. Then fifth operand is processed with some other operand, we will get sixth operand, like this. Okay, till the end of program we have to move like this. Okay, and push and pops are the two main opcodes to input and output from the stack. In case push command is there, then it is to input the data in the stack, and pop command is there, it is to remove the data from the stack from the top. So input will occur from the top, okay, as well as output will also occur from the top. Okay, so this is for pop. When we use pop command, it is removed. So hope by this small lecture you would have understood that how to categorize the instruction set of CPU with respect to the address points it is handling. Thank you.